Good evening, everyone. Ladies and gentlemen, a very warm welcome to all our distinguished guests, respected engineers, academics, industrial professionals, and students joining us from Sri Lanka and abroad. It is my great pleasure to welcome you all to this collaborative webinar series organized by the Sri Lanka Association of Institutions of Civil Engineers together with MIDAS India. Today's webinar marks the third session of an exciting learning journey through an exclusive five-part continuing professional development webinar series designed to bridge the gap between structural modeling and practical design. Today's webinar marks the third session of exciting learning journey through the exclusive part of continuing professional development webinar series. This expert-led series focuses on real-world infrastructure applications using Eurocode and provides participants with integrated structural and geotechnical workflows to model, design, and verify engineering projects with confidence. Over the course of this series, participants will explore 5 practical engineering projects using 3 powerful software solutions: MIDAS Gen, MIDAS Civil, and MIDAS GTS NX under the guidance of premier IIT alumni and senior technical expert from MIDAS IT. We are delighted to have each one of you with us this evening. Without further also, let us begin today's webinar on modeling to design in Eurocodes of deep and shallow foundations. Ladies and gentlemen, we will now watch a brief introduction video showcasing the Institution of Civil Engineers Sri Lanka and its contribution to engineering profession, and a short introduction to MIDAS India, highlighting its innovation engineering, software solutions, and commitment to advancing structural and geotechnical engineering. Thank you. It is now my pleasure to introduce our resource person for today's technical session, Mr. Mohammad Zulfekhar Ali. Mr. Ali is a senior technical support engineer at MIDAS IT India, holding a master's degree in structural engineering with over 6 years of professional experience in structural engineering. Uh, Design and finite element analysis, his areas of expertise including structural dynamics, bridge engineering, high-rise building, and advanced numerical analysis throughout his career. He has worked on a wide range of engineering projects, including pre-stressed concrete and composite concrete buildings, time history analysis, seismic isolation systems, and bridge loading rating. Is proficient in a wide range of industry-leading structural engineering software, including the MIDAS suite, uh, ETABS, StatPro, and AutoCAD, and has extensive experience applying international design standards. In addition to his technical expertise, Mr. Ali has conducted numerous technical webinars and continuing development workshops on advanced structural engineering topics, helping engineers translate theory into practical engineering solutions. Ladies and gentlemen, please join me in warmly welcome Mr. Mohammad Zulfekhar Ali, sir, yours.
Thank you so much for the brief introduction. Just share my screen. Hello everyone. I hope the
Yes,
screen
sir,
is
you are
visible.
audible and
Okay.
screen is visible.
So I welcome you all for the webinar on modeling to design in Eurocode of deep and shallow foundation. So before starting, like behind every iconic structure lies an invisible masterpiece. That is nothing but the foundation. Engineering practice begins where the structure meets the ground. Introduction to the foundations. Foundations are the lowest part of the structure that transfer all the superstructure to the soil or the ground. So the primary objective of foundation design is to ensure that all the loads are transmitted to the ground without causing excessive settlement, bearing capacity failure, and the instability. And foundation design is a multidisciplinary process involving both structural as well as a geotechnical engineering. So here we need the combination of both the structural engineers as well as the geotechnical engineer. When it comes to the foundations, they are broadly classified into two categories. One is a shallow foundation and other one is the deep foundation. So these classifications are done based upon certain features. First is the depth. So when your depth is very less, the foundation depth is very less, close to the surface, then it falls under the shallow foundation. And if it is more than 3 or deep, then it classified as deep foundation. And it depends upon the load capacity as well. So shallow foundations has moderate load carrying capacity, and deep foundations, when your structural loads are very high, and it also depends upon the soil requirements, whether you are having strong surface like rocks or dense sands, or weak surfaces with silty sands and clays. So when it comes to the low-rise buildings where the load is very less, then we go for the and your soil surfaces are having like strong surfaces, then we go for the shallow foundations. And when it comes to the high-rise buildings and the bridges, we go for the deep foundation. Now, second part is like selecting the foundation type. So which foundation we need to select? Again, it depends upon what is your bearing capacity of the soil and the settlement criterias and what are the structural loads coming from the superstructure and presence of the groundwater level and construction feasibility as well as the cost. So all these parameters will govern the selecting the foundation type. So based upon the soil conditions, if you're having high soil bearing capacity and low settlement criteria, then in that case we can happily go with the isolated foundations. And let's say our two columns are very closely spaced to each other, then where your isolated foundations are overlapping. In that case, we can go with the combined foundations. And if you are having low soil bearing capacity with many columns, in that way, raft foundation will be the suitable option. And if you're having weak upper soil layers, then we go for the pile foundations or the V foundation. And if you're having heavy structures or high-rise buildings, then we go for the pile raft foundation. So when it comes to the foundation systems that are commonly adopted in buildings and infrastructure projects are isolated foundations, okay? So we basically start with the isolated foundations. So for isolated foundations, we can model the isolated foundations separately, or we can also model in the global structure. So now, what is the advantage we can get when we model the foundations in the global structure? You can just type in the chat box. Do we have any advantages when we model the foundations along with the superstructure? So this is one of the example of isolated foundations that we have modeled. So basically in the engineering practice, we follow like modeling the supports and then we do the analysis of the structure and then we extract the reactions and then we do the design for the foundation separately. But what is actually happening at the site or the practical scenario when your building is resting on the foundations? So if you see this particular structure where you're having a column and below that it is modeled as a isolated foundation. So one thing is we give the real soil flexibility under the structure. So in the boundary conditions, we have different types of support conditions. So generally we provide the pin support or fixed supports at the bottom of the column. So which will give the zero deformation at the bottom after the analysis. But when we model the shell element as a isolated foundations and apply the surface springs. So in surface springs, we can provide the modulus of subgrade reaction in all the three directions. So there will be certain resistance for the soil in the vertical direction by compression behavior, and there will be some resistance in the lateral directions, global X and global Y direction. So we can enter the modulus of subgrade reactions provided in the geotechnical report in all the three directions, and we can apply to these particular foundation. Where these points things can be seen here. So now after running the analysis, when you go to the results and check the displacement contour for any of the load case along the vertical direction dz, along with the deformed shape and the values. And so I'll just undisplay these supports in support. And now I can change the units dynamically here to mm. And now I can see the units at the deformation or the displacement contour at the bottom of the column. So which is around 0.692 mm. Okay. So here it is a single column and the load applied is also very less intensity. But when it comes to the building, your axial loads and the movements will be higher, where it will increase the magnitude of this particular deformation at the bottom of the column. But when we give the pin supports or the fixed supports, it will show us zero deformation. But actually, there is a deformation happening at the bottom of the column. So, which we ignore by modeling the point spin support. So, what happens here is you'll be getting some additional forces and moments due to settlements that are happening in the foundation. So, that effect can be captured when you model the foundation along with the superstructure. So, this is first point, like advantage of modeling the foundations along with the superstructures in the same model file. Second thing is you can also check the stability criteria. So whenever we are doing the foundations, we have soil bearing checks, overturning or uplift checks, and the sliding. So when we apply these surface springs, we can also see the soil pressure, the vertical pressure, and the legend. So I can just change this to fixed format here, and units I can change to kilonewton per meter square. So based upon the load, here we are getting 60 kilonewton per meter square as the soil bearing pressure. So let's say I have the soil bearing pressure as 100 kilonewton per meter square from the geotechnical report. And because of the externally applied loads, my pressure is 60.31 kilonewton per meter square, which is less than the soil bearing capacity. And other thing is uplift or the overturning. So here the negative value indicates there is a compression in the foundation, and positive values include the tension. You can see this color contour in the blue color. There is slight uplift in the foundation. So you can see the moment is applied in this direction and this direction, so which will be creating a uplift or tension, or you can say no contact to the ground at this particular region. So in order to avoid the overturning or uplift, we need to make sure that the pressure here is either negative or greater, zero. So if it is positive, it indicates that there is a tension or uplift. And second thing is whenever we are modeling the foundations, your columns are modeled as line elements and foundations are modeled as stem. So when your line element is directly contacted to the plate element, there you can get more stress concentration. So which will give large amount of reinforcement at the connection region. But in reality, if you see this part of the foundation is completely rigid. So the column and the foundations are completely rigid. So in order to avoid that huge stress concentrations, we can model the rigid link based upon the size of the column. So that can be done easily in the software with the help of column capital. So if you go to the node and element tab, there you can find different options like drop panels and the column capitals. So first we can define a column capital, which is having the size of the column, let's say 0.2 by 0.2. And here we have the option of auto rigid link. So when you mesh the foundation, the software will automatically create the rigid link till the perimeter of that particular column. So here you can see once you create the column capital, you can assign that column capital to the column. And you can also specify the column capital, whether you want to locate at the bottom of the column or the top of the column. So when you are dealing with the flat slabs, then we go for the top of the column. And when you are dealing with the foundations, we select the bottom of the column. If it is sharing both, then we select the both here. And then we assign this column capital by selecting this column here. Now you can see after meshing, the software will create the rigid link based upon the size of the column. So this entire part is treated as rigid. Now you can see how it impacts in the analysis results. So after performing the analysis, I will just go to the results and check the plate forces and moments. So here we can select the load cases, static load cases, as well as like dead loads and the live loads. And we can also smoothen the forces by selecting the average nodal method. Here we can take the average of the connected elements at a common node. And mxx is the moment along the local x-axis. So if you see here, we can display the element local axis and the label. So this is our x, local x direction. So mxx is moment along the local x. And we scroll down and we don't want to deform shade and the legend and just hit on apply. So here you can see the plate force and moments in terms of kilonewton meter per meter width. And we can also visualize the shear force and the bending moment diagrams in the plate elements using the cutting line diagram option. So here you can see the cutting diagram feature where you can select that cut lines and we can just hit on apply. So now here you can see the difference in the results when you model the column directly connecting to the plate elements and other one is with the help of rigid link. So this is the moment basically that is the face of the column. So that is 51.6 kilonewton meter per meter, and here it is a peak moment 161.8 kilometer meter per meter. So that is where we observe the peak moments when we model the line elements directly in contact with the plate element. So it is a good practice to model as a rigid below the column wherever it is at least the cross-sectional area which is having that particular rigid link. So manually creating that rigid links is a complex job, but in MIDAS Gen you can make it very easily just by defining the column capitals and the automation so that you will be getting the lesser reinforcements as well in the foundation. So these are the few things when we come with the foundations in a single model file. We can see the global behavior, and second thing is automatic rigid links with the help of column capital, which will reduce the peak movement. So before modeling the shell elements, now the question is how to decide the size of the foundation. So there are many columns in a building. Then how to decide the size of the foundation? Just type in the chat box. How do you decide the size of the foundation? Am I audible? And am I audible?
Yes, sir.
Okay. So the I have one question for the attendees, like how you are going to decide the size of the foundations before modeling it as a shell element. So few may do manual calculations using the Excel sheet by exporting all the reactions to the Excel sheet, which is again a time consuming process. Yes, based upon the load and the SBC. So we export all the loads to the Excel sheet and make sure that the stress criteria is satisfied. And from there, and we also consider the bearing capacity of the soil. And then we finalize the size of the footing. Okay. So instead of doing this manually, where it will consume lot of time, and for example, let's say there are any modifications in the model, then you need to do all these repetitive steps again, right? So instead of doing all these manual calculations, MIDAS Gen provides a solution with the help of MIDAS Design Plus. So let me show you the solution now. So basically, in the software, we can do the superstructure as well as the substructure in the same model file, and we can also automatically generate the load combinations or we can also replace the existing load combinations if there are any modifications in the load cases. So generating the load combinations is automatic in the software. And now we can see it's a part of the building is on pile truck foundations and part of the building is on the isolated foundation. So I want to know what are the sizes of the foundations based upon the load and the soil bearing capacity. So in MIDAS Gen, we have interesting tool that is Design Plus, where it will help us in providing the sizing of the RC members. Either it may be beam, column, or the foundation. So we can link with MIDAS Gen and extract all the reactions required for the design. So we can link these to the Gen and we can import all the data. So either it can be isolated footing or combined footing. And here we can also select by maximum or individual members. And load combination type, we can select it as all the load combinations and force type as reactions of the support. And here we can see once we have selected these particular supports, the node number will be highlighted in the design plus and we can import all the data. So basically we need the reactions for the foundation. So here you can see all the column data has been imported in one click. So if there are any modifications, you can make the modifications and just import it. So here you can see strength and serviceability load combinations. And we can also include some additional surcharge load. And here we can also restrict the maximum thickness of the foundation required for the design. And we can also set the rebar limits as well. So what should be the range of my rebar for the footing? And we can also specify the spacing of the rebars required for the movement. So here we can find both the options, design and check. And if you want to design all the foundations, we can design in a single go. So before doing the design, we can make sure the soil bearing capacity. So by default, it will be 3 meters by 3 meters. But now you can see the optimum size of the footing required based upon the loads and the bearing capacity. So you can also generate the drawings for the footings and extract the quantity of the steel as well as the concrete for the foundations. So this is how the Design Plus tool helps in providing the sizing of the foundation, generating the drawings, and the quantity of the steel and concrete. And another interesting part is you can report, or we can extract the report in the detailed format. So here we can see the reports can be either in detailed format in Word document or Excel or the text file. So similarly, based upon the Eurocode, we can also do the strict foundation designs, combined foundation designs in the design plus based upon the empirical calculations. And for detailed finite element designs, we can model it as a shell element and we can do the design in the software. So we have mesh design feature. We can select the Eurocode and here we can do the slab flexure design, shear design, and serviceability checks. So in shear checking, we can see the punching shear checks based upon force method and stress method. And in the serviceability checks, we can see the stresses in the concrete and the reinforcement, crack control, like crack width, minimum area of steel, rebar spacing and the rebar diameter, and deflection. So deflections can be uncracked or cracked deflections by considering the creep coefficient for the long-term deflection. So this is how you can do the detailed designs for the isolated foundations once you get the sizing of the foundation. So here design plus makes our job easier in the foundation design. Next one is the combined footings. Okay, the sub concept of the foundations is similar now, like a boundary conditions. In combined footings, footings are combined each other. So here we can see these are the combined footings which are modeled, where you have two columns and the foundations. So we can also do the foundation designs in the design plus as well, based upon the empirical methods or the procedure given in the code. Yeah, next one is the strip fountains. So sometimes along with the foundations, we also need to strengthen with the help of beams, additional beams. So in the software, we can also model the strip foundations in the global model. So when I activate it all, so this is my global model where I can model the strip foundations and I can see the realistic behavior of the structure and additional strength due to these particular beams. So when these foundations are not satisfying the criteria, so we start with isolated, then we go for combined strip, and then we go for the raft foundation. So whenever it is coming to the raft foundations, there are few interesting things. First is the shear deformation. So shear deformation play important roles in soil structure interaction, particularly the mass soil interaction. So generally we ignore the shear deformations, but shear deformations play a major role in the flexure behavior of the plate, which makes the plates more flexible. Okay. So when your structure is flexible, the moments, the forces demand will be lesser. But when it comes to the serviceability point of view, the deflections will be higher. So we need to balance both the things. So when comparing the thin versus thick plate modeling, thick plate deforms more yielding, which will give a smaller design moment. So therefore, generally we recommend using the thick plate modeling for the analysis and the design of the mat foundation. So basically, we will be having two types of plate elements, thin and thick. So when we just go to the elements, we can select the plate element, and in that we have thick as well as a thin. So in thick plate elements will be used for the mat foundations whose thickness is considerably higher. So basically the out of plane stiffness used in MIDAS Gen includes two types. One is discrete Kirchhoff elements and other one is DKMT. So these are developed based upon the thin plate theory and Kirchhoff plate theory. So whenever we are using the thick plates, it exhibits the super performance for the thick plates as well as the thin plates by assuming the shear strain fields to resolve the shear locking problem. So here we can see the advantage of shear deformations. So where you will be getting more deformations compared to the normal element, but the design forces and moments will be reduced due to the flexibility of the structure. So here you can see the difference in the moments, even though the elements and the loads are all the same. This has some higher moments and lesser moments. But again, here the nodal loads are applied directly at this particular location, so which is creating a peak moment. And there is a sudden reduce in the moment after a certain distance. So in order to avoid these peak moments, we generally use the column capitals for creating the rigid limit. Otherwise, at this location, we will be getting the higher reinforcement. So if still the rack foundations is not solving our concern, then we go for the pile foundations. So the pile foundations will be depending upon different construction sequences. So we can drill it and then insert the reinforcement cage and then pour the concrete. And but every construction has its own advantages and disadvantages. So when you drill this particular pile and insert the reinforcement cage, there may be chance of collapse of the soil and con- and there will not be complete compact or the bond between the reinforcement and the concrete. So in that case, we go for the driven piles or the precast piles. So the advantage of these precast driven piles is for this we have high quality concrete due to controlled manufacturing and we can immediate load carrying capacity after the installation. So we need not to wait for getting the strength, complete strength of the concrete or the curing. And there is no risk of the borehole collapses. And installation will also be relatively faster and minimum dependence on the groundwater condition. So these are the advantages. But it has some limitations as well. So when you drive these piles, it generates significant noise and the vibration and Transportation and lifting can be challenging for the long piles, and length adjustment on sites are limited and not ideal for near sensitive structures where vibrations must be minimal. So now these piles are combined with a raft. So either they can be isolated pile cap foundations or pile raft foundations. But whenever you create a pile foundations, along the depth of the pile, there are different soil layers. Either it can be having the lower density soil, medium density soil, or higher densities. So we need to perform the borehole test and extract the soil data along the depth of the pile. And based upon that, we need to calculate the stiffness of the soil. And as we know, the soil is non-linear behavior. So along with the deformation, the stiffness will gradually reduce. So either we can provide the equivalent linear stiffness or we can model it as a force deformation function using the PY curves. So the boundary conditions for the piles will be the force deformation functions, which we need to calculate. So here you can see the variation of the stiffness. So as the deformation increases in the soil, the stiffness will gradually reduce. And at certain point of time, even though there is a slight force, the deformation will be continued. So this will be the reversal of the direction. So the piles can be moving in this direction or the soil can move in the opposite direction. So the stiffness we just consider as a symmetrical one and we define the pile springs. So in the software, we have direct option of providing the pile spring support where we can just input the geotechnical data like what type of soil is available at the site. So when we go to the boundary conditions, here we can find the pile spring supports where you can select the soil type, whether you are having sand or soft clay or stiff clay, and the ground level of the pile. Okay, so this will be the ground level of the pile and the pile diameter and unit weight of the soil present at this particular location and at pressure coefficients, modulus of subgrade reactions, internal friction angle, and initial soil modulus. So whether it is a dense sand or loose sand or the medium sand. So based upon this input, the software will automatically calculate the force deformation functions based upon the Lehman theory. And if I see from the side view, so along the depth of the pile, the properties may change. So as you can see in this particular diagram, so till this part of the pile, you are having the lower density, and again, this part of the pile, you are having the medium density. So what we can do is we can select piles which are having same soil properties, and we can assign the string. And then you can change the parameters here, and you can select the other layer of the pile elements and apply. So once we apply, You can see all the inputs in the tree menu. In the boundary condition, you can see the springs are applied, linear springs are applied in the vertical direction, and multilinear links are present in the lateral direction. So X and Y, we are having the multilinear springs. So these multilinear springs will be having the force deformation functions. So if you see the properties, so this will be the behavior of the multilinear spring. So again, this is an iterative method. So first we assign some strings and then we run the analysis and we check the results and then we make the modifications in the strings till the results converge. So this we can do with the help of empirical calculation. So for example, we have our own set of calculations for finding the PY curves. So instead of defining these functions one by one, it's going to the force deformation functions and adding the force deformation functions. We can automate the things with the help of API. So now in GenNX, you can find that API where you can connect with any programming tool. Either it can be Excel, Python, Grasshopper, and we can automate the things. So for that, we have developed a tool which is PY Cross Automated. So what exactly this tool does is, so let's say we have a building with the file caps that are already created, and now we need to create the file and apply the springs. So here we can directly input or link all the PY calls in the Excel sheet for the formation functions, and we can have the reference nodes here for the files, and we can specify the reference node and the metadata and the section IDs. So here you can see the workspace menu. In the boundary conditions, right now we have only the support. So once I click on create PY curve, it will create all the post deformation functions as per the data given in the Excel sheet. And once I hit on create files, it will create the files and apply the multilinear springs. So this is how we can make the things faster with the help of API. So automation will make our work simpler. So till now we have seen line modeling as well as the plate elements. But when you go for heavy foundations like machine foundations or very deep racks, so in that case we use solid elements for the modeling. So like machine foundations or the raft foundations which are having very huge thickness, we generally use the solid elements. So, but whenever we model the solid elements, how we will extract the forces? So, my question is like when we model the solid elements, how do we extract the forces?
Yes, sir.
Am I audible? I
Yes,
am
yes,
waiting
sir.
for the response. Like, if you are modeling the solid elements, how to extract the forces. So let's say this is one of the example of machine foundation where you'll have the solid, and you can also see the depth of these particular foundations with the help of query nodes option, which is 4.5 meters. Okay. And length of this foundation is around 141 meters. And here we will perform the dynamic analysis for the check of the foundations. So here we will be having the heavy machine foundations and apply the dynamic nodal loads onto that particular foundation. And where your time forcing functions will be periodic by reaching a maximum amplitude of 8,000 kilometers. So after performing the analysis, we can see the stresses for the solid elements, whether the limit is, whether the stresses, tensile stresses and compressive stresses are within the permissible limit or not. So this is one check, and other is like extracting the forces and the moments for the solid elements. So that can be done with the help of local direction force sum. Okay. So let me show you how this local direction force sum will work. So for a particular solid element, we can cut a section here and we can extract the resultant forces for that particular solid element. So let me show you the process. So here we have modeled two different elements. One is the line element and other one is the solid element. And this is a simple cantilever beam just to verify the results, which is subjected to a nodal load at the free end. So when because of that load, we are getting a moment of 625 kilonewton as a moment and the shear force as 250 kilonewton. So whenever we model the same thing as a solid element and we want to extract the force and the moments, then in that case, we can use this local direction force sum feature for the solid elements. So in the results, you can find this local direction force sum and the type of elements you can select as a solid, and you can cut a section where exactly we want to see the forces. So we can directly see the results here, or we can also give the name to that particular section and we can extract the results in the tabular format. So I have given name as support and extract the results in the table for all the load cases or the combinations. So now you can see we are getting the same forces and the moments that we got for a line element. So moment is 625 kilonewton meter. So this is how we can extract the forces in the solid elements when we are dealing with the solid foundations, which are having large depths. So another challenge that we get when we are modeling such type of deep foundations is the heat of hydration. So you know that concrete will follow the exothermic reaction where it will release the heat when it is gaining the strength. So if you see these particular foundations, the outer surface is exposed to the temperature atmosphere, so it will release the heat very easily. But if you go to the inner parts of this particular block foundation, so it will generate the additional stresses. So once the stresses are increased, then it will try to generate the cracks. So before doing such mass concreting, we need to make sure that our structure is safe. So for that, we perform special type of analysis, which is known as heat of hydration, by considering the creep and the shrinkage of the concrete. So with respect to the time, your creep coefficient will increase, and because of loss of water, your shrinkage will also get increased, which will create the higher stresses with respect to the time. And we also pour the concrete in different sequences, and we also need to capture that behavior. So for that, we do heat of hydration in different stages. Okay. So let me show you one simple example of the foundation. So this foundation is completely modeled as a solid, and we have two different materials. One is the mat foundations, and other one is the subsoil. So for subsoil, we have given the soil properties, and for mat, we have provided the concrete properties. And then we include the time-dependent material properties. So here you can select the code, like European code, and you can define the properties like characteristic compressive strength and the notional size, class of cement that you are using, and code. So based upon that, the software will calculate the creep coefficient variation with respect to the time and the shrinkage strain variation with respect to the time. So these are the few important things that we need to consider when you are dealing with the concrete structure, the creep and shrinkage effects, and the elasticity variation with respect to the time. Then we apply the boundary conditions. So here we'll be having entire soil, and then we provide the ambient temperature. Okay, so what is the normal temperature? And then we have the convection coefficients. Okay, so based upon the exposure of these particular concrete, how much heat it can be released. So based upon that, we provide the boundaries. So if I display these convection boundaries, so here it is open to the atmosphere. And then we will be having the heat source functions like how the heat is generated in the concrete with respect to your time. So we have function with respect to the time, which is a function of maximize adiabatic temperature and reactive velocity coefficient. And sometimes these heat source functions may change based upon the concrete data that we're using. So based upon the cement type that you are using, moderate or high early strength, blast furnace or fly ash, and the temperature, and based upon the cement content, the graph of heat source function will vary. So complete results will be depending upon the how the heat source is developed. And these particular blocks are like pouring of the concrete has taken in different stages. So let's say in first stage, only this part of the concrete is poured, and then we take a break, and then second pour of the concrete will take place. So this is how the sequence of pouring of the concrete can be simulated in the software. And when the stresses are more than the permissible limit, then we go for the pipe cooling procedure. So we can introduce the pipe which are passing through the pool or pool water, and which will reduce the temperature stresses internally. So we can also check the behavior of the structure in the presence of the pipe cooling. And after performing the analysis, we can see all the heat of hydration related results, like how the stresses are developed in the concrete with respect to the time. Okay, I can see the stresses in. So here it is 15. So 1.48 positive value represent the tensile stresses and negative value represent the compressive stresses. So if these stress values will increase the permissible limit, then cracks will be developed. So after 200 hours, the stress is 1.64, and after 220 hours, it is 1.88. So the stress value is gradually increasing 2.06, 2.02. Okay. So after certain peak, then again the stresses will come back to the normal. So it will go to the peak level and then again it will try to reduce. So we need to make sure that at that particular peak level, our concrete is safe in the crack. And you can also see the temperature variation. So you can see the temperature is varying till 52 degrees Celsius. And after 1100 hours, then again it has been gradually reduced to 36. And we can see the allowable tensile stresses and the crack ratios in the structure. So this is one of the important analysis that can be easily handled in GenMX when you are having the mass concreting structure. So either it can be raft foundations or the wind turbine foundations, machine foundations. So that can be easily handled with the help of heat of hydration analysis. So another challenges that we face is related to the soil structure interaction. So the procedure that we have seen previously is completely based upon the empirical methods, finding the PY curves and updating the PY curves in the model. But when it comes to the important structures, the realistic approach is by performing the 3D geotechnical analysis by creating the soil in a 3D continuum model. So if you see here, this particular structure is analyzed and designed by assuming certain springs. Initially, we assume certain force deformation function, and then we model exact 3D soil model in the geotechnical software. So we have geotechnical analysis software known as MIDAS GTS-NX, which is known for advanced geotechnical analysis like soil structure interactions, deep excavations, tunnels, etc. So today we'll focus on the soil structure interaction application, and we have good powerful link with the geotechnical software. So it is very important to have the proper link between structural analysis software and the geotechnical analysis software, because at the end of the day, the soil structure interaction is an iterative process. You need to do some iterations to and fro until you finalize the stiffness of that particular springs. So what you can do is we can assume certain force deformer functions and we do the analysis, and then we send the entire 3D model along with the reactions to the geotechnical software, and there we model the 3D continuum soil and do the analysis. So from there we get the realistic settlement behavior of the structure and the spring stiffness. So that force deformation functions will be sent to GenNX, and there we run the analysis to check whether there is convergence happened in the results or not. So if it is not done, then we can send the reactions again. So this is how the iteration takes place. But doing this manually is again a little bit time consuming process, because we need to wait till the analysis has been done and then export it. So instead of that, we have tried to automate this iterative process with the help of NX Interact plugin. So that plugin will automate the process. So even we don't have the geotechnical software, we can also connect with some other clients who are having this particular geotechnical tool, and we can do the iterative analysis. So I will show you a simple example. And before that, so these are the few real projects where the soil structure interaction has been done for the high-rise building. So the global model is done in Gen NX, and in GTS we have modeled the soil based upon the exact profiles. So we, as you can see, the soil is varying along the length and the width of the formation. So this is to handle the soil structure interaction. So if you see this particular image, then there is one more additional challenge. So there is already a existing building, and below the existing building there is some tunnel construction. So now we want to see the perform the risk assessment for this particular building. during the tunnel construction. So here you can, in the geotechnical analysis software, you can capture the effect of the superstructure because of the tunnel construction. So another challenge that we frequently face is like construction of the buildings adjacent to the tall structures. So when we do the deep excavations, so we need to see the behavior of the adjacent structure as well. So such type of challenges can be easily handled by MIDAS GTS NX in combination with MIDAS Gen NX. So with the help of these tools, we can do the complete structural and geotechnical analysis. So for this, we have developed NS Interact plugin where it will exchange the data between the both the softwares. So let us see that. So this is simple model of file foundation. So initially we have applied some force deformation functions based upon the empirical calculations that we have made. And then we run the analysis for this particular model and we get some reactions which we can export this to the GTS NX software. So this MXT file will export the geometry of the structure. So we can easily import that structure into the geotechnical software. So this will save a lot of time in creating the model from the scratch. So now you can see entire model has been imported. And then we just quickly create the soil model by defining the properties of that particular soil. So we have some advanced tools for creating the geometry and meshing. So we define the soil properties of mood column and we have different material models that are readily available. And we can also simulate the groundwater level. And it is also do the automatic mixing and apply the boundary conditions. And we perform the analysis to check the soil stiffness and settlement. So now we get the results related to the settlements. So now with the help of this NX Interact, we can link the Gen software with the help of API. So even the programs are installed in different computers, you can easily exchange the data. Let's say you have the geotechnical software and I have the structural software GenNX. I can share my mapping key with you so that you can input the mapping key in the NX Interact and you can directly connect the models. So first it will run the analysis in the GTS NX and then it will send the data to the GenNX automatically with the help of API, and there it will run the analysis and bring the updated nodal results. So based upon the number of iterations we specify here, it will do the iteration. So we not to worry about like when the analysis will be completed and we need to export the data, exchange the files. So you can just put it for analysis and we can relax. So this is how the API will be helpful in automation and reducing the time in the workflow of the project. Now let us see the practical example using MIDAS Gen NX and GTS NX, especially for the file draft foundation. So this is one of the upcoming tallest tower in the world. This is Jeddah Tower in Saudi Arabia. So the height of the structure is around 1 kilometer, and the structural analysis is done using MIDAS Gen NX by Totten Tomshetty. You can see the different construction stages for this particular high-rise building. So when it comes to the foundations, these particular structure have pile raft foundation. So the pile raft foundation is done using MIDAS GTS NX. So engineering consultant was Lanka International for geotechnical analysis and Totten Tomshetty for the structural analysis for the superstructure. So it is still under construction is going on, and that is having pile rock foundations, and the height of the structure is 1008 meters. So this is upcoming tallest tower, which is taller than the Burj Khalifa. So in this particular project, so both the softwares are utilized, Gen as well as the GP. Gen for the column shortening analysis of the tall building, and GTS-NX for the foundation paragraph analysis. So you can see the different soil models. So next one is the settlement analysis. Settlement is another challenge in the structure. So Leaning Tower of Pisa, which is again one of the structure which is affected by the differential settlement. So to capture the settlements, you need to model the soil as the soil model as well as the superstructure. So because of the settlements, you also generate some additional force and manage in the structure. So this is one approach to do the detailed settlement analysis. And another approach is we can apply the settlement values to the column location. So let me just open the model.
Yes, audible.
My screen is visible, right?
Yes, sir. Yes, it is easy.
So let's say this is my superstructure where I know the settlement values. So we can just go to the loads and we can go to the settlement and we can specify the settlement group. So here you can select all the nodes of the column which are having the same settlement. Let's say the highlighted nodes are undergoing 10 mm deformation and similarly the different so different columns undergo different settlements. So based upon that we can create the groups. So and we can also do some load cases like where we can capture like different effects like when two different groups settle simultaneously by doing some permutations and combinations. So in this way we can capture the settlement behavior and we can perform the settlement analysis by providing the settlements at different columns. So when it comes to the pile foundations, we can just model the pile foundations and we can apply the spring supports to the piles based upon whether they are friction piles or end bearing piles. So according to that, we can provide the spring stiffness to the piles. Or if you are modeling in the geotechnical software, then we can also provide that interface between the soil and the pile, and we can do more realistic analysis. And this is little bit simplified analysis. So again, we need to check the structure is safe in stability, bearings, and the sliding. So this we already seen that our structure is complete in the compression, or if there is any uplift, or these values exceeding the soil bearing capacity. So for this, basically, we for the particularly for the foundations, we refer to Eurocode 1997 for the geotechnical design part. This one we already seen in the previous webinar, like for load calculations and the concrete design. We refer the code 1992. So this is where we have discussed about the heat of hydration analysis, where we can define the heat source functions for the concrete and the time-dependent material properties, and then heat transfer. Okay. So definition of the ambient temperatures and the heat, and temperature distribution based upon the construction or the pouring sequence. So from there, we can see how the temperature is varying during the construction and the stresses in the concrete. So we can also use pipe cooling approach to reduce the crack and control of temperature for the use of ice plant by determining initial temperature for newly activated elements at the corresponding construction stages. And we also need to consider the various parameters for the accurate track index analysis. So first one is the adiabatic temperature rise, considering the maximum adiabatic temperature and relative velocity coefficient, creep shrinkage, and changes in the ambient temperature as well as the convective coefficient. So convective coefficient will be depending upon the existence and the type and thickness of the formwork. So convection of the heat depends upon the type of the formwork that you are using and the curing method and the wind velocities. So a lot of parameters will be depending for the convective coefficient. So till now we have discussed much about the analysis part. Now the design. Okay. So again, designs depends upon the behavior of the members. Okay. So basically, when we see the foundations, mostly you'll be having the flexure behavior, where we can go for the design using the mesh design, and we can perform the slab flexural designs. So when we do the slab flexural design, the software will provide us what is the rebar required and area of steel in terms of mm² per meter. So based upon this area of steel, we can provide the reinforcement. So we can also reduce the uniformity here. We can go to the contours and we can customize the range. So at these locations, we will be having the nominal area, and at these particular locations, we will be having some higher area. And next interesting part is the wood armor movements. Okay. So whenever we check the results for the plate forces and moments, we just get the forces and moments per meter width. Okay. And again, we need to find what is the moment at the top and bottom in direction one and direction two. So that can be captured by the software. The software will automatically calculate the wood armor moments. So if we go to the wood armor moments, so based upon the applied load, the software first will calculate the wood armor moment for the transformed axis. Okay, so for example, if you're having circular foundations for the tanks where you want to produce the radial reinforcement and the tangential reinforcement. So in that case, we want to get the movements in that particular direction, radial as well as the tangential direction in the top and bottom. So whatever the forces that we are getting, it will be transferred into the transformed axis, and from there it will calculate the wood armor moment at the top and the bottom, direction one and direction two. And based upon the wood armor moment, the software will do the design. And in the design, we have two options. One is design and checking. So in the checking, we can provide our own reinforcement in the rebar input. We can provide our own reinforcement pattern for the slab, mat, or walls and shelves in top and bottom, direction 1 and direction 2, and we can check whether the provided reinforcement is safe or not. And then we can see the shear checking, okay, the punching shear checks. So here we can also select certain elements and we can do the design only for that particular member. Instead of doing the design for entire structure, I can just focus on certain elements. Okay. And then we can do the punching shear checks. So here you can see the punching shear checks. So when the ratio is more than 1, then we can do some additional thickness at that particular point. So that can be done very easily by providing the drop panels at that particular column. Okay. So if you want to increase the thickness only at certain part, you can do the drop panels of that size so that we can dynamically increase the thickness at that particular location. Instead of increasing the thickness for entire foundation, you can increase the thickness near the columns using these particular drop panels. So this will be satisfied when you're having the flexural behavior. So next one is the wall designs. Okay. So let's say we have some vertical plate element where it will be taking the axial forces as well as the uh, in-plane moments. Okay. So in that case, we can use say wall design. And another thing is shell flexural designs or the shell design. So let's see the behavior of the shell. So basically, when you use the slab, it is governing in flexure, particularly out of plane bending. So when your plate element is governing by out of plane bending in flexure and shear, then slab design will be the correct approach. But if your flexure is governing in plane and in plane shear and the axial, in that case, meshed wall design will be the correct. But if you want to capture both in plane as well as the out of plane, so that can be captured by the shell elements. Okay. So shell elements can take both in plane flexure as well as out of plane flexure, in plane shear and out of plane shear, and axial effect also. So what is the example, real-time example for the shell? Can you just type in the chat box for one real-time example for the shell elements where you will
Opera,
be having
Sydney Opera.
Sydney?
Sydney Opera, sir.
Okay, so meaning of in plane and out of plane. Okay. So let's say we are having this plate element. Am I audible?
Yes, sir. Yes, sir.
Okay. So when you are having a plate element, so for example, if it is a horizontal, okay, so this plate will bend like this, okay. So this is out of plane bending. So this behavior happens when your load will be acting perpendicular to the plate, okay. Another one is in plane, okay. For example, if you're having a wall, vertical wall, and you are having forces in the this direction, okay. So these forces will create the in plane effects, okay. So when the loads are perpendicular to the plate, then it will create the out of plane effects, okay. So in shear walls, mostly you will be having the lateral loads, okay. So these lateral loads will create the in plane effect, and in slabs you will be having the vertical load, that is perpendicular load, which will create the out of plane. So when it comes to the buildings with the retaining walls, okay, so you are having a retaining wall which is connected to the building, and that is connected to the slab. So here you are having the slab. So because of this slab you will be getting some axial load, and because of some lateral loads you will be getting the in plane, and here you will be having some earth pressure loadings, okay. So this earth pressure will create the out of plane bending effect and the axial effect as well as the in plane, okay. So retaining walls in the buildings, we will be having this behavior where your axial is also governing, out of plane is also governing, and the lateral is also governing. So in that case we can take the advantage of the shell design, so which will be capturing both the effects of in plane as well as the out of plane. So this is one of the frequently asked question. If there is a retaining wall, let's say up to first floor or second floor, how to model it, and do we need to have beams over the retaining walls, and can we include the retaining walls in the same building model? So for that I want to show you one simple example of the building. So this is the entire building model, and here till 4 basement levels you will be having the retaining walls, okay, and then you have the columns and the shear walls. So if I just activate it, so along the periphery you are having the walls, and then intermediate you will be having the beams or the walls, okay. So for this you can just model it as a meshed plate element, and so that you can do the shell design, and can connect with the other elements as well. So this one you can model as a plate element, and you can create a mesh, and when you are creating the subdomain you define that particular elements as a shell element, okay. And how to assign the lateral loads for these particular retaining walls. Okay, so for lateral loads or the earth pressure loads, we have inbuilt function in the software. So when we go to the loads, in the lateral loads, first we can define the parameters of the soil. Okay, so whatever the type of the soil it may be, you can define the uh, angle of internal friction and the density, because your soil pressure will be depending upon psi as well as the gamma. So at different layers you can define the properties here. So when whatever the elements that are falling in this range, let's say 3 to -15, the software will automatically apply the earth pressure. So here you can define the different layers with the different properties for the soil friction angle and the density, and then we can assign the static earth pressures. Okay, so while defining the static earth pressure, here you can select the load case names and the xy direction, whether you want to apply in the global x is 0 and global y it is 90, or some if it is arbitrary direction you can also select as normal to that plate. And here you can specify whether you want to apply, whether the coefficient should be at rest or active earth pressure, and if there is any additional surcharge loads to the live loads or the dead loads you can add it here. And if there is any water level you can add the water level and the surcharge load, and you can select the properties of that particular soil, and you can select the planar element for which you want to apply the earth pressure. Okay, and the software will automatically calculate the earth pressure along the depth that we have specified here. And we can also see the detailed calculation sheet. Okay, so if you are selecting at rest, according to Jackie's formula, earth pressure at rest is 1 minus sine phi, and soil stress friction angle and the soil density equation. So this is the earth pressure equations considering the water levels and the soil surcharge and all. So here you will be getting the soil pressure along the depth. So with the help of this function, the software will automatically calculate the earth pressure and apply on the plate elements, and you can also extract the detailed calculation reports. So here you can see the water level, there is a variation in the earth pressure, and you can find the detailed calculation reports. So this is how we can model the different types of foundations in the software, and we can do the mesh design. We can also consider the crack section analysis for the long term and serviceability checks. Okay, so as per Eurocode we can do the serviceable stress checks, track control and the deflection checks. And we can also use the design place tool for the foundation designs. Okay, so it can be a regular foundations or it can be pile foundations where you can specify the number of piles, and it can be a eccentric foundation in one direction or both the direction. So here we can do the designs as well as the checks, and we can also deal with the combined foundations, and you can also provide the load values can be directly imported from the GenNX, and you can also add the number of columns based upon the requirement. So the combined footing can be with 2 columns, 3 columns, or the 4, or you can add n number of columns. And you can also handle with strip footings. Either it can be rectangular type of strips or inverted T type of strips with a single rebar or double rebar, and you can provide the soil bearing capacity here by changing the units in terms of kilonewton per meter square and the splicing data. And we can input the forces, or we can link with the GenNX and import the forces here. So this is one of the example of performing the strip footing design using the design plus. So if you are having the beams at this location and you want to do the strip footing design as per the Eurocode, we can select that particular beams, and the number of the member number will be updated here, and we can import the analysis results from GenNX. And we can do the design as well as the checks. So in the right you can see the detailed calculation reports, and we can also change the section shapes and do the design. So this is how we can handle all types of foundations with the advanced analysis and the soil structure interaction. So thank you so much for being patient with me for 2 hours. Now if you have had any questions, I can just take it up. Please feel free to type in the chat box so that we can have the discussion regarding the foundations. Why not directly use shell design to model all walls so as not to use beams at floor levels? Uh, the question is not clear for me. Can you please elaborate, like not to use beams at floor levels? Not to use beams at floor levels. Can you please elaborate the question? How can MIDAS Gen be used to model a circular water tower foundation? Okay, so even in case of circular foundations, you can model it as a circular plate element. Just let me open one water tank model. Okay, so when you are coming with the circular tanks, so we can create the model for circular tanks, and based upon that we can just specify the uh, rebar direction for the design. Okay, so you can model the circular uh, bottom of that particular water tank, and again you can do the mesh design. Okay, now in the mesh design again you have two options. Let's say we have the circular bottom of that particular tank. So in that circular bottom you can provide the reinforcement in the both the directions. Let's say, so this is two different patterns in the reinforcements of the circular slabs. Okay, so if you see here, one is radial and tangential. Okay, so this is case one, where you will be having one radial reinforcement and other one is the tangential reinforcement. And the second case is global to x and y direction, which is perpendicular to the each other. So this is the second case and this is the first case. Okay, so based upon the pattern that is required we can align our local axis, so that whenever you are doing the design the software will calculate the forces and the moments with respect to the local axis and get the reinforcement required. Okay, so if you want perpendicular to each other, then the second case, and if it is radial and tangential, then the first case. Modeling will be same, like you need to make a mesh elements, and according to that you need to do the design. So direction of reinforcement and local axis can be adjusted based upon the requirement. To refresh, are all wall modeled as shells regardless of whether they serve as retaining wall or internal shear walls? And if not, why won't you do this? So if you want to model the shear walls as a shell elements, you can model it as a shell element, and you can also do the design for that. But similar to that behavior, already we have wall element, a wall element where you can select it as a plate. Okay, so just let me share the screen. So whenever you are going to node and element and the create elements, for shear walls, when you select the wall element you have two options. One is membrane as well as the plate. Okay, so if you select it as a plate element, then the behavior will be similar to the shell, but here it will be considering the in plane moment as well as the out of plane moment along with the axial force, but not out of plane shear. So based upon your requirement you can model the wall elements as well using the shell. If you want to consider out of plane shear as well, you can model it. Sir, is the drop panel or pedestal you are provided for isolated footing? It's not drop panel or pedestal. It's just a rigid link uh, to simulate the column shape. Okay, so just I will explain in the paint. So basically, you have a isolated foundation, and this is your column. Generally, when you model, if you see the elevation view, this is a plan, and this is the elevation view. Okay? And if you see the finite element modeling, you will be having a plate element like this and a line element like this. So here it is creating a stress concentration at this particular point. It is acting like nodal loads here at this. But in reality, your entire column is connected to the foundation, not just a single line. Okay. So to simulate that your entire column is connected. So basically, this part of the footing will be rigid. Okay. So this part of the footing will be rigid. So if you are designing any moment here, we consider the moment from the face of this particular column. And if you just model it as a single line, you will be getting some peak moment here. Okay. But if you see from the face of the column, the moment will be released reduced drastically. So these peak movements are due to connection of the line elements to the plate elements. But in reality, it is not a line, it is a like solid. This part of the column is solid, which is completely behaving as a rigid. So to simulate that, we use rigid links to connect the periphery nodes of that particular foundation. So if you are having nodes along the periphery of the column, it will connect with the rigid link. So instead of manually doing this rigid link, we use column capital in the software. It's not a drop panel, it is a column capital. So which will automatically do this process for us so that you can uh, overcome these particular peak movements in the foundation design. It's not a drop panel or pedestal, it's only just a column. I am very interested to ask about the Taj Mahal is supported on deep well foundations near the Yamuna River. Can MIDAS Genetics model the interaction between these foundations wells and the surrounding soil using the springs, supports, or soil structure interaction? How would this influence the model periods and the seismic response? Okay. Yeah, you can also handle with the well foundations as well in the software. So it again depends upon the level of detailed responses that are required. Okay, so it can also be done based using the line elements, or you can also model the well foundations using the solids or the plates. Okay, so if you want to provide the springs along the surrounding of the well, then in that case modeling the well foundation as plate elements will be the suitable approach. Or if you want to go for equivalent by just considering the well section properties, you can also use it as a line elements. So solid well foundations. Okay, so this is the models for the well foundations. So we can model it as a line element for a simplified analysis, and you can just apply the spring supports, equivalent spring supports, by considering the section properties. Okay, so I can just display the sections with some random color. So till this part I'm having the solid, and I will activate inverse, and then followed by the circular shape, and then based upon that again you have the different sections. Okay, so this is the well plug section, and you have the well section with the circular thing, and bed block, and the pier base, and whatever the superstructure that you are having above that particular well. And another is you can model it as a solid element. Okay, so you'll be having the opening and completely modeled as a solid element, and then you apply the supports along the periphery face of these particular solid elements, and then you apply all the loads acting on these particular well. So the nodal loads and the wind or something. So you can model that well foundations, either line or plate or solid elements, based upon the detailed of the results that are required. I think you will be receiving the certificate of the participation. Thank you so much clearing my doubts, and I learned many interesting insights today. Thank you so much. How much deflection allowed in the pile? So these for this is completely like we need to refer the code, like the deflection limits in the piles. When the pile diameter is increasing, better than increasing pile length during the design of pile. When the pile diameter is increasing, better than increasing pile length during the design of a pile. So pile length and pile diameter, you can just, it's like for the capacity of that particular section, but length also depends upon like whether it's a friction bearing pile or end bearing pile. So that is again like iterative type, length and the diameters. How to model the pile which are subjected to horizontal lateral forces. How to sub- Anyhow, in the global structure, you will be having the lateral forces. I hope I have answered all the questions from the chat box. Still, if you have any questions, you can feel free to contact us.
Yes, sir.
So, thank you so much. Yes,
Yeah, can you, sir, pass the control,
sorry.
the sharing option? Can you, sir, send?
Uh, Actually, I did not get you. What you are saying?
Could you pass the sharing option?
Sharing option. Okay, okay. I think it's done.
Okay. Well, thank you very much, Mr. Mohammad Zulfekhar Ali, for that insightful and highly informative lecture. We sincerely appreciate the time, expertise, and the practical knowledge you have shared with us this evening. As a gesture of our sincere gratitude for an excellent and enlightening session, we would now like to present token of appreciation to our keynote speaker, Engineer Mohammad Zulfekhar Ali. Please accept our token of appreciation.
Thank you so much.
Thank you once again, sir, for your valuable contribution. Uh, as we come to the close of today's session, I would like to once again express my heartfelt gratitude to our keynote speaker, Engineer Mohammad Zulfekhar Ali. And thank you, sir, for sharing your knowledge and expertise with us during today's webinar. Also, I would like to thank MIDAS India for their generosity to collaborate with SLAICE and facilitate this workshop for our fellow engineers and students. We truly appreciate your efforts.